Hello there, and welcome back to Whispers of Science, where the universe reveals its secrets in the softest tones and wonder takes its time to unfold. Tonight, we're embarking on a journey that might just change how you see yourself forever, because we're asking one of the most beautiful questions science has ever dared to whisper. So, are we truly made of star stuff? And if you're settling into bed, curling up somewhere cozy, or just letting your mind wander after a long day, you've found the perfect place to explore this cosmic mystery together. Before we drift into the depths of space and time, I'd love to know where in the world you're listening from tonight. And when you look up at your local sky, what do you see, perhaps? A few scattered stars peeking through city lights. Or maybe, if you're fortunate enough, a vast tapestry of glittering diamonds scattered across velvet darkness either way. Those distant lights hold secrets about you. Secrets we're about to uncover gently and thoroughly. If you find this celestial voyage soothing, or simply a peaceful way to end your day, I'd be ever so grateful if you gave this video a gentle thumbs up and perhaps subscribed to join our quiet community of cosmic wanderers. It helps these whispered explorations reach other curious souls who might need a moment of wonder in their lives. Now, I do hope this isn't so fascinating that it keeps you wide awake, but if it does, well, at least you'll drift off knowing something profound about your place in the cosmos. So take a deep breath, let your shoulders relax, and let's begin this extraordinary story that connects every atom in your body to the heart of ancient stars. The idea that we are made of star stuff isn't just poetic language from daydreaming astronomers. It's one of the most remarkable scientific discoveries of the past century, a revelation so profound that it bridges the gap between the vastness of space and the intimacy of our own existence. When the late Carl Sagan first popularized this phrase, he wasn't speaking metaphorically. He was sharing a literal truth that emerges from our understanding of stellar evolution, nuclear physics, and the grand recycling program that is our universe. But what does it actually mean to say we're made of star stuff? And how did the atoms that make up your heart, your thoughts, your very breath come to exist in the first place? To understand this, we need to travel back, not just through space, but through time itself, to the very beginning, when the universe was young, hot, and remarkably simple. Imagine, if you will, the universe as it existed roughly 13.8 billion years ago. In those first moments after what we call the Big Bang, the cosmos was nothing like the rich, complex tapestry we see today. There were no stars, no planets, no galaxies, no atoms as we know them today. Instead, there was an incredibly hot, dense soup of fundamental particles, protons, neutrons, and electrons, all swirling in a cosmic dance of creation. As the universe expanded and cooled, something remarkable happened. These particles began to stick together, forming the very first atomic nuclei, primarily hydrogen with its single proton, and helium with two protons and two neutrons. These were the only elements that existed in any significant quantity for millions of years. The universe was essentially a vast cloud of hydrogen and helium with just trace amounts of lithium scattered throughout like seasoning in a cosmic broth. Now, here's where our story becomes particularly enchanting, because these primordial elements, hydrogen and helium, would become the raw materials for the universe's first great construction project. The birth of stars' gravity, that invisible architect, began pulling together these clouds of gas, creating denser and denser regions until something magical happened. The pressure and temperature at the center of these collapsing clouds became so intense that nuclear fusion ignited. Nuclear fusion is perhaps one of the most beautiful processes in the universe. It's the cosmic alchemy that transforms simple elements into more complex ones. Deep within the core of a star, hydrogen nuclei collide with such tremendous energy that they overcome their natural repulsion and fuse together, creating helium, and in the process, releasing enormous amounts of energy. This energy is what makes stars shine, what provides the light and warmth that sustains life across the cosmos. But fusion doesn't stop with helium. Oh no, the universe is far more creative than that. As stars age and evolve, they begin fusing helium nuclei together, creating carbon, then oxygen, then silicon and iron. Each step in this process requires higher temperatures and pressures, as if the star is working harder and harder to continue its cosmic cooking. This is where our story takes a dramatic turn, because not all stars live peaceful lives. Some, the most massive ones, lead lives of spectacular intensity and meet equally spectacular ends when a star much more massive than our Sun exhausts its nuclear fuel. It faces a crisis. The outward pressure from fusion that has supported it against gravity's inward pull suddenly disappears, and the star begins to collapse. What happens next is one of the most violent and beautiful events in the universe. A supernova explosion in the span of seconds. A dying star releases more energy than our Sun will produce in its entire 10 billion year lifetime. The temperatures and pressures during this cosmic catastrophe are so extreme that they forge elements that could never be created inside a normal star gold, silver, platinum, uranium. All the heavy elements that make our world so wonderfully complex are born in these stellar death throes. But here's the truly remarkable part. When a star explodes as a supernova, it doesn't just create these heavy elements, it hurls them out into space at tremendous speeds, seeding the surrounding cosmic neighborhood with the building blocks of complexity. These stellar ashes drift through space for millions of years, mixing with clouds of hydrogen and helium, creating a richer, more diverse cosmic soup, and then gravity works its magic again, pulling together these enriched clouds to form new stars. And this time around, the story is different, because now there are enough heavy elements to form something unprecedented: rocky planets, like our Earth, with oceans and atmospheres, and all the chemical complexity necessary for life to emerge. So when we say we are made of star stuff, we're talking about a literal truth that spans billions of years of cosmic evolution. The calcium in your bones was forged in the heart of a dying star. The iron in your blood was created during a supernova explosion. The oxygen you breathe right now was produced by fusion reactions in stellar cores that burned billions of years before our solar system even existed. Every atom in your body, except for hydrogen, has been through this remarkable journey from the core of an ancient star through the violence of stellar death and explosion across the emptiness of space, and eventually into the clouds that would become our solar system, and ultimately into you. It's a story of cosmic recycling on the grandest possible scale, where the death of one generation of stars provides the raw materials for the next. But the story doesn't end there, because we're not just passive recipients of this stellar inheritance. We're active participants in the ongoing cosmic story. The carbon you exhale with every breath will one day become part of a plant, or perhaps dissolve in the ocean. The atoms that make up your body will eventually return to the earth, and over geological time, some of them will make their way back into space to continue the endless cycle of cosmic renewal. This realization has profound implications for how we see ourselves and our place in the universe. We're not separate from the cosmos. Looking in from the outside, we are the cosmos, we are the universe, becoming aware of itself through billions of years of evolution, from stellar nucleosynthesis to planetary formation to the emergence of life and consciousness. When you consider that the same physical laws that govern the fusion reactions in stellar cores also govern the chemical reactions in your cells, when you realize that the same gravitational forces that shape galaxies also keep your feet planted firmly on the ground, you begin to understand that there's no meaningful distinction between us and the universe we inhabit. We are not visitors here. We are natives, children of the stars coming home to understand our origins. This perspective has a way of putting things in their proper context. The petty concerns that occupy so much of our daily attention fade into insignificance when measured against the cosmic story of which we're all part. Yet paradoxically, this same perspective makes every moment more precious because we are the universe's way of experiencing beauty, love, wonder, and consciousness. The next time you look up at the night sky, remember that you're not just looking at distant lights, you're looking at your stellar ancestors, the very stars that forged the elements of your existence. Some of those points of light are still in the process of creating the heavy elements that future generations of planets and perhaps life will depend upon others, have already completed their cosmic mission, exploding in spectacular supernovas and seeding space with the materials for new worlds. And here on Earth, every time you breathe, you're participating in this ancient cosmic cycle, taking in oxygen that was created in stellar cores billions of years ago, and exhaling carbon that will continue its journey through the carbon cycle of our planet, and eventually, perhaps beyond every heartbeat, every thought, every moment of wonder you experience, is the universe celebrating its own creativity and complexity. This is just the beginning of our exploration into the profound connections between ourselves and the cosmos. In the next part of our journey, we'll delve deeper into the specific processes that forge the elements we're made of. We'll explore how scientists discovered these stellar connections, and we'll uncover even more remarkable ways that we are intimately connected to the stars above. So, as you settle into whatever peaceful corner of the world you call home tonight, remember that you carry within you the legacy of countless stellar generations. You are quite literally a child of the stars, a walking, talking, dancing, dreaming collection of ancient stellar ashes that somehow learned to love and wonder and ask questions about its own origins. The universe took billions of years to create you, and every atom in your body has its own incredible story to tell a story of cosmic violence and beauty, of stellar birth and death of elements forged in the hearts of stars and scattered across the galaxy by explosive stellar winds and supernova shockwaves. In our next exploration, we'll discover exactly how scientists uncovered these cosmic connections and learn about the specific stellar processes that created the elements flowing through your veins. Right now, we'll meet the stars responsible for your existence and understand the remarkable chain of events that led from stellar cores to your consciousness. Until then, sleep well knowing that you are made of star stuff and that the same atoms that once danced in the hearts of ancient stars now dance within you, carrying forward the universe's most beautiful story, the story of how simple hydrogen became complex enough to wonder about itself. But how exactly did scientists come to understand this profound connection between ourselves and the distant stars? The story of this discovery is itself a tale of human curiosity and ingenuity, a detective story that spans centuries and required some of the most brilliant minds in history to piece together clues scattered across time and space. It began, as many great discoveries do, with someone simply looking up and wondering. In the early 1800s, a German optician named Joseph von Fraunhofer was studying sunlight through a prism, much like countless others had done before him. But Fraunhofer noticed something peculiar that others had overlooked. The rainbow spectrum of sunlight wasn't smooth and continuous. Instead, it was crossed by hundreds of dark lines, like someone had drawn fine black threads across the colors. These mysterious lines puzzled scientists for decades. They appeared not just in sunlight, but in the light from other stars as well, each star showing its own unique pattern of dark interruptions in its spectrum. It was as if each star was speaking in a coded language, and humanity had yet to learn how to translate the message. The breakthrough came when scientists began studying the light emitted by different elements here on Earth. When they heated various substances in their laboratories, each element produced its own characteristic pattern of bright lines in the spectrum. Sodium always produced the same yellow lines. Hydrogen created specific red and blue patterns, and iron generated its own complex fingerprint of spectral lines. The revelation was breathtaking. Those dark lines in starlight weren't random. They were the exact opposite of the bright lines produced by elements in laboratory flames. When light from a star's hot surface passed through cooler gas containing specific elements, those elements absorbed light at precisely the same wavelengths they would emit when heated. It was like finding a photographic negative of elemental signatures imprinted in starlight. Suddenly, scientists realized they could determine what stars were made of simply by analyzing their light. This technique, called spectroscopy, became astronomy's most powerful tool for understanding the cosmos. For the first time in human history, we could reach across the vast emptiness of space and touch the very atoms that made up distant suns. What they discovered was remarkable. The same elements found on Earth, hydrogen, helium, carbon, oxygen, iron, existed in the stars as well. The universe, it seemed, was made of the same fundamental building blocks everywhere. But this raised an even deeper question. If the elements were the same, how did they come to exist in the first place? The answer began to emerge in the early 20th century as scientists started to understand the incredible energies locked within atomic nuclei. They realized that the sun and other stars weren't burning like cosmic campfires instead. They were powered by nuclear fusion, a process that could transform one element into another. Hydrogen, the simplest and most abundant element in the universe, was being converted into helium deep within stellar cores, releasing tremendous amounts of energy in the process. This was the first piece of the stellar alchemy puzzle. But scientists soon realized that fusion could go much further than just creating helium. In the most massive stars, the process continued step by step, building heavier and heavier elements: carbon from helium, oxygen from carbon, silicon from oxygen, and so on, all the way up to iron. The story took a dramatic turn when astronomers began studying stellar explosions. They had long observed what they called novae, bright new stars that would suddenly appear in the sky, shine brilliantly for a time, and then fade away. But in the 1930s, they discovered something far more spectacular: supernovae, stellar explosions so violent they could briefly outshine an entire galaxy containing billions of stars. These cosmic catastrophes weren't just impressive light shows, they were cosmic factories operating under the most extreme conditions imaginable. The temperatures and pressures generated during a supernova explosion were so intense that they could forge elements far heavier than iron elements like gold, silver, platinum, and uranium that could never be created in the steady burning of normal stellar cores. But perhaps most importantly, these explosions didn't just create heavy elements, they scattered them throughout space. The shockwaves from supernovae hurled stellar ashes across thousands of light years, enriching the surrounding cosmic environment and providing the raw materials for future generations of stars and planets. This realization led to one of the most beautiful insights in all of science. We are not just made of matter that happened to be lying around when Earth formed. We are made of matter that was carefully crafted over billions of years in the nuclear furnaces of stars, seasoned in the violent crucibles of stellar explosions, and delivered to our corner of the galaxy by cosmic winds that carry the ashes of dead stars across unimaginable distances. The evidence for this stellar heritage is written into every atom of your body. The calcium that gives strength to your bones was forged in the core of a massive star that burned for millions of years before exhausting its fuel and collapsing in a spectacular supernova. The iron that carries oxygen through your bloodstream was created in the final moments of that same stellar death when temperatures reached billions of degrees and atomic nuclei were slammed together with tremendous force. Even more remarkably, different elements in your body have different stellar pedigrees. The carbon that forms the backbone of every organic molecule in your cells was created in smaller, longer-lived stars through a delicate process that required precise conditions to work properly. The oxygen you breathe was produced in massive stars that lived fast and died young, exploding after only a few million years of existence. Some elements that tell even more exotic stories. The gold in any jewelry you might be wearing wasn't just forged in a supernova, it may have been created during the collision of two neutron stars, the ultra-dense remnants of stellar cores that somehow found each other across the cosmic void and merged in a cataclysmic event that sent ripples through the fabric of space and time itself. This cosmic genealogy means that your body is quite literally a museum of stellar evolution. Every breath you take contains atoms that have been on extraordinary journeys through space and time. Some of the hydrogen in the water molecules flowing through your veins may be nearly as old as the universe itself, created in the first few minutes after the Big Bang and never altered since. Other atoms have had more eventful histories. The nitrogen that makes up a significant portion of the air in your lungs was created in the cores of intermediate mass stars, stars too small to explode as supernovas, but large enough to cook hydrogen into heavier elements through millions of years of nuclear burning. Scientists have even been able to trace the specific stellar processes responsible for creating different isotopes of the same element. The carbon 12 in your body was made through one process in stellar cores, while the much rarer carbon 14 was created by cosmic rays striking nitrogen atoms in Earth's atmosphere. Each isotope tells its own story of cosmic alchemy and stellar craftsmanship. This understanding has revolutionized how we think about our place in the universe. We are not separate from the cosmos, looking up at it from the outside. We are the cosmos, we are the universe, becoming aware of itself through billions of years of physical and chemical evolution that began in the hearts of the first stars and continues today in the cells of our bodies. The water you drink, the food you eat, the air you breathe, all of it carries the signature of stellar nucleosynthesis. The very thoughts passing through your mind right now are made possible by neural networks built from atoms that were forged in stellar cores billions of years before our solar system even existed. This perspective transforms even the most mundane moments into something profound. When you stretch your hand toward the sun, you're reaching across space with matter that was created by stellar fusion. When you look up at the night sky, you're using eyes built from stellar ashes to observe the very process that created you. When you feel your heart beating, you're experiencing the rhythm of life, powered by energy that ultimately traces back to nuclear reactions in the cores of ancient stars. The story becomes even more remarkable when you consider that this process of stellar nucleosynthesis is still happening today. Right now, as you listen to these words, stars throughout our galaxy are fusing hydrogen into helium, helium into carbon, and carbon into oxygen. Massive stars are in the final stages of their lives, preparing to seed space with heavy elements through spectacular supernova explosions that will provide the raw materials for future worlds and perhaps future life. We are part of an ongoing cosmic story, not just the passive recipients of stellar generosity, but active participants in the universe's continuing evolution. The atoms that make up your body will not remain with you forever. Through respiration, digestion, and the constant renewal of your cells, you are continuously exchanging matter with your environment. The carbon you exhale today may become part of a tree tomorrow, and the calcium you consume will eventually return to the earth, perhaps to be incorporated into new life forms or swept up into space by solar winds to continue the cosmic recycling program. In this sense, we are temporary arrangements of stellar matter, patterns of organization that persist for a brief time before the atoms that compose us continue their journey through the universe. We are the cosmos experiencing itself subjectively, consciousness emerging from the complex dance of particles that were born in stellar cores and will outlive us by billions of years. This realization brings with it a profound sense of connection, not just to the stars above, but to every living thing on Earth. The tree outside your window, the bird singing in its branches, your pet sleeping peacefully nearby, all of them are made from the same stellar materials. All of them carry within their atoms the legacy of cosmic evolution. We are all, quite literally, siblings, in the truest sense, children of the same stellar parents, born from the same cosmic processes that have been operating for billions of years. As we continue our exploration, we'll delve even deeper into the specific mechanisms that created the elements flowing through your veins right now, and discover how the ongoing process of stellar evolution continues to shape not just the cosmos around us, but the very possibility of life itself. The process of stellar nucleosynthesis is like a cosmic cookbook that has been perfecting its recipes for over 13 billion years, and each element in your body tells the story of a different stellar chef working under vastly different conditions. Let's journey deeper into these stellar kitchens and discover exactly how the atoms that make you who you are came to exist. Picture, if you will, a star roughly 8 times more massive than our Sun, burning brightly in a galaxy far away and long ago. In its core, temperatures reach 15 million degrees Celsius, hot enough to strip electrons from atoms and create a plasma so dense that a teaspoon would weigh as much as a car. Here, in this inferno of unimaginable intensity, hydrogen nuclei are moving so fast that they overcome their natural electrical repulsion and slam together in the first step of stellar alchemy. This process, called the proton proton chain, is deceptively simple in concept but breathtakingly elegant in execution. 4 hydrogen nuclei dance together in a cosmic ballet, ultimately fusing to create one helium nucleus, releasing energy in the form of photons that will spend thousands of years bouncing around inside the star before finally escaping as the gentle sunlight that warms your face on a spring morning. But this is just the opening act. As our stellar furnace ages and the hydrogen in its core becomes depleted, something remarkable happens. The star begins to contract under its own gravity, and the core temperature rises even higher. At 100 million degrees, a new process begins: helium burning. 3 helium nuclei come together in what scientists poetically call the triple alpha process, creating carbon in a reaction so delicately balanced that if the nuclear forces were even slightly different, carbon would be impossible to make. This carbon is not just any carbon, it's the carbon that forms the backbone of every protein in your muscles, every strand of DNA in your cells, every neurotransmitter that carries thoughts across the synapses in your brain. The carbon atoms in the coffee you might be sipping right now were forged in stellar cores when the universe was young, when entire galaxies looked nothing like they do today. As our stellar chef continues its work, the core grows ever hotter and denser. At 600 million degrees, carbon begins fusing with helium to create oxygen, the same oxygen that flows through your bloodstream right now, carried by iron atoms that have yet to be born in our stellar story. At 1 billion degrees, oxygen itself becomes fuel, fusing to create silicon, magnesium, and sulfur, the silicon that strengthens your bones, the magnesium that helps your muscles contract, the sulfur that gives structure to your hair and skin. Each burning phase happens faster than the last, as if the star is rushing towards some cosmic deadline. Carbon burning might last for thousands of years, but silicon burning lasts only days. The star has become an onion of elements, with each layer burning a different fuel: hydrogen in the outermost regions, then helium, then carbon, then oxygen, and finally silicon in the innermost core. But here's where our story takes a dramatic turn. Silicon burning produces iron, and iron is where stellar fusion reaches a dead end. Iron nuclei are the most stable configuration of protons and neutrons possible. Fusing them together doesn't release energy, it actually requires energy. When the core fills with iron, The nuclear fires that have supported the star against gravity for millions of years suddenly go out. What happens next occurs faster than you can blink. The star's core, no longer supported by the outward pressure of fusion, collapses from the size of Earth to the size of a city in less than a second. The density becomes so extreme that electrons and protons are crushed together to form neutrons, releasing a flood of ghostly particles called neutrinos that pass through matter as if it weren't there. The collapsing core bounces when it reaches nuclear density, sending a shock wave racing outward through the star at 30,000 kilometers per second. This shock wave is the herald of one of the most spectacular events in the universe, a core collapse supernova. In the span of seconds, the dying star releases more energy than it produced during its entire multi-million year lifetime. The temperatures and pressures in this cosmic furnace are beyond anything that exists in normal stellar cores. Elements that could never be created during peaceful stellar burning are forged in abundance. The shock wave itself becomes a particle accelerator, slamming lighter nuclei together with such violence that they stick, creating gold, platinum, silver, and uranium, the precious metals that have fascinated humanity throughout history. But perhaps most remarkably, this explosion doesn't just create these elements, it hurls them into space at speeds of tens of thousands of kilometers per second. The outer layers of the star, enriched with all the products of millions of years of nuclear burning, are blasted across hundreds of light years, creating an expanding bubble of hot gas called a supernova remnant. This stellar debris doesn't simply disappear into the cosmic void. Instead, it mingles with the interstellar medium, the thin gas that fills the space between stars, enriching it with heavy elements and triggering the formation of new stars and planetary systems. The shock waves from supernovae can compress nearby gas clouds, causing them to collapse and ignite new rounds of star formation. In this way, each stellar death becomes the seed of new stellar births. The calcium in your teeth was likely created in the silicon burning shell of a massive star just hours before that star exploded as a supernova. The phosphorus that forms the backbone of your DNA was forged in the same stellar inferno, then blasted across space by the explosion and eventually incorporated into the cloud of gas and dust that would become our solar system. Some elements tell even more exotic stories. The gold in any jewelry you might own wasn't created in a supernova at all, but rather during the collision of two neutron stars, ultra-dense stellar remnants that spiraled into each other over billions of years, before merging in a cataclysmic event called a kilonova. These collisions are so rare that all the gold ever mined on Earth represents the debris from perhaps a handful of such cosmic crashes that occurred in our galactic neighborhood billions of years ago. The iodine that your thyroid gland uses to regulate your metabolism was created by a completely different process, the slow capture of neutrons in the atmospheres of dying red giant stars. These ancient stellar giants, in their final gasps of nuclear burning, synthesized iodine through a gentle process that took thousands of years, a stark contrast to the violent creation of elements like gold and platinum. Even more remarkably, scientists have discovered that different types of stars contribute different elements to the cosmic mix. Low-mass stars like our Sun, which live for billions of years, are the primary source of carbon and nitrogen. Intermediate mass stars produce much of the neon and magnesium in the universe. The most massive stars, which live fast and die young in spectacular supernovas, are responsible for most of the oxygen, silicon, and iron. This means that your body is quite literally a sampling of the entire history of stellar evolution in our galaxy. The hydrogen in your body is nearly 14 billion years old, created in the first few minutes after the Big Bang when the universe was hot and dense enough for nuclear reactions to occur naturally. The helium in your breath was created both in those first moments and in the cores of countless stars over the past 13 billion years. The heavier elements tell stories of specific stellar generations. The carbon in your cells was created in stars that lived and died before our sun was born. The oxygen you breathe was produced in massive stars that exploded as supernovae, seeding space with the raw materials for future worlds. The iron in your blood was forged in the final moments of stellar collapse, when gravity temporarily overcame the fundamental forces of nature. What makes this story even more profound is that it's still happening. Right now, as you listen to these words, stars throughout our galaxy are in various stages of this cosmic recycling program. Some are quietly fusing hydrogen into helium, as our sun has done for nearly 5 billion years. Others are in more advanced stages, burning helium into carbon or carbon into oxygen. A few massive stars are in their final moments, their cores filled with iron and teetering on the edge of collapse. Somewhere in our galaxy, perhaps once every 50 years, a star explodes as a supernova, briefly outshining billions of other stars and ejecting the products of stellar nucleosynthesis into space. These explosions are so energetic that they can be seen across billions of light years, beacons announcing to the universe that another stellar generation has completed its mission of element creation. The elements created in these stellar forges don't remain in space forever. Gravity, that patient cosmic architect, gradually pulls the enriched gas into new clouds, which eventually collapse to form new stars and planetary systems. Each generation of stars is slightly richer in heavy elements than the last, as the universe slowly transforms from the simple hydrogen and helium of its youth into the complex chemical symphony we see today. Our solar system formed from one such enriched cloud roughly 4.5 billion years ago. By that time, billions of stellar generations had lived and died, each contributing their elemental gifts to the cosmic mix. The rocky planets like Earth could only form because previous generations of stars had created the silicon, iron, magnesium, and aluminum needed to build solid worlds. The water in Earth's oceans tells its own remarkable story. The hydrogen was created in the Big Bang, but the oxygen was forged in stellar cores and distributed by supernova explosions. When these two elements found each other in the cold depths of space, they formed water molecules that eventually rained down on the early Earth, creating the oceans that would cradle the first stirrings of life. Life itself is only possible because of this cosmic heritage. The carbon-based chemistry that underlies all living things requires not just carbon, but also nitrogen for amino acids, phosphorus for DNA and energy storage, sulfur for protein structure, and dozens of trace elements that serve as cofactors in biological processes. Every one of these elements has its own stellar origin story, its own journey from the core of an ancient star to the cells of your body. When you breathe, You're participating in a process that connects you directly to stellar nucleosynthesis. The oxygen entering your lungs was created in the core of a massive star that died billions of years ago. That oxygen traveled across space for eons before becoming part of Earth's atmosphere, and now it's enabling the chemical reactions that power your thoughts and dreams. The carbon dioxide you exhale will continue this cosmic journey. Some of it will be absorbed by plants and converted into organic compounds through photosynthesis. Some will dissolve in the oceans, eventually becoming part of the shells of marine organisms. And some, over geological time, will escape Earth's atmosphere and return to space, continuing the endless cycle of cosmic recycling. This perspective transforms how we think about death and renewal. The atoms that make up your body are not permanently yours. They are on loan from the universe, temporarily organized into the pattern that is you before continuing their cosmic journey. When you die, these atoms will return to the Earth, and eventually, some of them will make their way back into space through processes like volcanic outgassing and atmospheric escape. In the far future, when our sun exhausts its hydrogen fuel and swells into a red giant, it will gently puff off its outer layers, returning much of its material to space enriched with the products of helium burning. Some of the atoms that are currently part of your body may be swept up in this stellar wind and carried across the galaxy to become part of future stars and worlds. This cosmic perspective doesn't diminish the preciousness of life. Instead, it reveals life to be even more remarkable than we might have imagined. We are not separate from the universe, looking in from the outside. We are the universe itself, organized into temporary patterns of extraordinary complexity and beauty. We are the cosmos becoming conscious of itself, asking questions about its own nature and marveling at its own creativity. The next time you look up at the stars, remember that you are seeing your own deep history written in light across the sky. Those distant suns are your stellar ancestors, the cosmic furnaces that forge the very atoms of your existence. And somewhere among them, new stars are being born from gas clouds, enriched by ancient supernovae, continuing the endless cycle of stellar death and rebirth that has been shaping the universe for over 13 billion years. This cosmic recycling program has been operating for so long that some of the atoms in your body have likely been through multiple cycles of stellar birth and death. The iron flowing through your veins might have been created in a supernova explosion 8 billion years ago, then spent eons drifting through space before being incorporated into a second generation star, which itself lived and died before our solar system even formed. That same iron atom could have been part of an asteroid, a comet, perhaps even another planet, before finally finding its way into the primordial disk that would become Earth. What's truly breathtaking is that we can trace these atomic biographies through the tools of modern science. By studying the isotopic ratios of different elements, scientists can determine not just where atoms were created, but when. Some of the stardust grains found in meteorites are older than our solar system itself, tiny time capsules that preserve the signatures of stellar processes that occurred before the sun was even a glimmer in a cosmic cloud. These pre-solar grains tell remarkable stories. Some bear the chemical fingerprints of red giant stars that gently expelled their outer layers in stellar winds. Others carry the signatures of asymptotic giant branch stars, elderly suns that pulsed and flickered as they died, creating clouds of carbon rich dust that drifted through space for millions of years. A few rare grains even preserve the isotopic evidence of nearby supernovas, their surfaces scarred by the radiation from stellar explosions that occurred in their cosmic neighborhood. When you hold a meteorite in your hands, you're literally touching pieces of other worlds, fragments of asteroids that formed from the same stellar ashes that created Earth. The elements in that space rock traveled the same impossible journey as the elements in your body, from stellar cores to interstellar space to the solar nebula and finally into solid matter. In a very real sense, you and that meteorite are siblings, born from the same cosmic materials and shaped by the same fundamental processes. But perhaps the most profound realization is that this stellar heritage connects us not just to the past, but to the future as well. The same processes that created the elements in your body are still at work throughout the universe. Right now, in stellar nurseries like the Orion Nebula, new stars are condensing from clouds of gas and dust enriched by countless previous generations of stellar death and rebirth. Some of these newborn stars will have planetary systems, and if conditions are right, some of those worlds might eventually harbor life. The atoms that currently make up your thoughts and dreams will outlast you by billions of years. Long after your consciousness has faded, the carbon in your cells will continue its cosmic journey. Some of it might become part of future trees, breathing carbon dioxide from an atmosphere that no longer contains any trace of your exhaled breath. Some might sink into the Earth's crust and eventually be subducted into the mantle, only to emerge millions of years later in volcanic eruptions that reshape continents. And in the very distant future, when our sun begins its final transformation into a red giant, the increasing solar luminosity will boil Earth's oceans and strip away its atmosphere. The atoms that once composed every living thing on our planet will be swept up in the solar wind and scattered across space, carrying with them the chemical legacy of 4 billion years of terrestrial evolution. Some of these atoms will drift in the interstellar medium for eons, gradually mixing with material from other stellar deaths and births. Eventually, gravity will gather them into new clouds, which will collapse to form new stars and new worlds. In this way, the atoms that are currently reading these words will participate in cosmic stories we can barely imagine, perhaps becoming part of life forms on worlds that won't exist for billions of years. This perspective reveals something profound about the nature of identity and consciousness. We tend to think of ourselves as discrete individuals, separate from the world around us, but the reality is far more interconnected. The boundary between self and cosmos is largely an illusion created by the temporary organization of matter into the pattern we call our bodies and minds. Every 7 years or so, most of the atoms in your body are replaced through the normal processes of metabolism and cellular renewal. The you that exists today is quite literally made of different stuff than the you that existed a decade ago. Yet your consciousness persists, your memories remain intact, and your sense of personal identity continues unbroken. This suggests that what we call self is not the atoms themselves, but rather the pattern of organization, the information encoded in the arrangement of matter. From this viewpoint, We are temporary eddies in the cosmic flow of matter and energy, brief concentrations of complexity in a universe that tends toward disorder. Yet somehow, through processes we're only beginning to understand, this organized matter has become capable of thought, emotion, creativity, and wonder. We are the universe contemplating itself, cosmic matter arranged in such a way that it can ask questions about its own origins and destiny. This realization brings with it a profound sense of responsibility. If we are indeed the cosmos becoming conscious of itself, then our actions and choices have cosmic significance. The way we treat each other, the way we care for our planet, the knowledge we create and preserve, all of these become part of the universe's ongoing story of self discovery. The elements in your body will outlast you, but the patterns of organization that make you who you are, the thoughts you think, the love you give, the beauty you create, these are more fragile and precious. They depend on the continued existence of complex, organized systems like brains and cultures and civilizations. In caring for these systems, we are caring for the universe's capacity to know and understand itself. When you consider that the calcium in your bones was forged in stellar cores, that the iron in your blood was created in supernova explosions, that the oxygen in your lungs was produced by nuclear fusion in massive stars, it becomes clear that you are not just made of star stuff. You are star stuff that has learned to wonder about stars. You are the cosmos dreaming about itself, matter organized into patterns so complex and beautiful that they can contemplate their own existence. This cosmic perspective doesn't diminish our humanity. It reveals humanity to be even more remarkable than we might have imagined. We are not accidents or afterthoughts in an indifferent universe. We are integral parts of the cosmic story, the latest chapter in an epic tale of increasing complexity and consciousness that began with the first stars and continues today in every act of kindness, every moment of wonder, every question we ask about our place in the grand scheme of things. The next time you feel small or insignificant, remember that you carry within you the legacy of stellar generations stretching back billions of years. The very atoms of your existence were forged in cosmic furnaces of unimaginable power and scattered across the galaxy by stellar winds and supernova explosions. You are quite literally made of the stuff of stars, and every breath you take, every heartbeat, every thought that passes through your mind is a celebration of the universe's creativity and complexity. And as you drift toward sleep tonight, perhaps in a few moments, or perhaps after we've journeyed a bit further together, know that the same atoms that are settling into rest within your body once danced in the hearts of ancient stars. They have traveled impossible distances and witnessed cosmic events of breathtaking beauty and violence. They have been part of stellar births and deaths, planetary formations, and the emergence of life itself. Now they are part of you, participating in the most remarkable phenomenon we know of in the universe, the emergence of consciousness from cosmic matter. As you sleep, these stellar atoms will continue their work, maintaining the chemical processes that sustain your life, encoding your memories, and preparing for another day of wonder and discovery. Tomorrow, when you wake, you'll still be made of star stuff, still carrying within you the legacy of cosmic evolution that stretches back to the very beginning of time. And somewhere in the galaxy, new stars will be born from the ashes of old ones. continuing the endless cycle of stellar death and rebirth that connects us all to the deepest mysteries of existence. But our journey into the cosmic connections doesn't end with the formation of elements in stellar cores. There's another layer to this story, one that reveals even more profound links between ourselves and the universe we inhabit. It's the story of how these stellar ashes were assembled into the complex molecules that make life possible, and how the same physical laws that govern the cosmos also govern the intricate chemistry of living things. When the elements created in stellar cores were first scattered into space by supernova explosions, they didn't immediately form the complex organic compounds we associate with life. Instead, they began a much slower process of chemical evolution, gradually combining in the cold, dark regions between stars to form the first simple molecules that would eventually become the building blocks of biology. In the vast molecular clouds that drift through our galaxy, temperatures hover just a few degrees above absolute zero, and the density is so low that a volume the size of Earth might contain only a few kilograms of matter. Yet, even in these seemingly barren regions, chemistry happens. Stellar atoms stick to tiny grains of dust where they can meet and bond in ways that would be impossible in the high energy environment of a star or the chaos of a supernova explosion. Here, in the cosmic equivalent of a gentle chemistry lab, carbon atoms created in stellar cores begin to form chains and rings, combining with hydrogen to create organic molecules. Oxygen joins the dance, forming water and alcohols. Nitrogen contributes to the formation of amino compounds. Sulfur adds its own distinctive chemistry to the mix. These are the same molecular families that form the basis of all life on Earth, being created in the depths of space billions of years before our planet even existed. Space telescopes have detected over 200 different molecules in these interstellar clouds, including some surprisingly complex organic compounds. There's methanol, the simplest alcohol, and formaldehyde, a key building block for more complex organic chemistry. There's hydrogen cyanide, which, despite its toxic reputation on Earth, is actually a crucial precursor to amino acids and nucleotides. There are even hints of more complex molecules, including some that might be precursors to the sugars and lipids essential for life. This means that when our solar system formed 4.5 billion years ago, the raw materials for life were already being delivered along with the stellar ashes from which our planet condensed. The organic chemistry that we think of as uniquely biological actually has its roots in the cold depths of interstellar space, where stellar atoms first learned to dance together in the complex choreography that would eventually become life. The water in your cells tells an even more remarkable story. Every water molecule consists of one oxygen atom created in the core of a massive star and two hydrogen atoms that are nearly as old as the universe itself. When these elements combined to form water in the cold outer regions of the solar nebula, they created not just a simple compound, but a molecule with almost magical properties that would prove essential for the emergence and evolution of life. Water's ability to dissolve so many different substances, its unusual density properties that cause ice to float, its capacity to store and release large amounts of heat. These characteristics arise from the quantum mechanical properties of atoms forged in stellar cores billions of years ago. The same nuclear processes that created oxygen in stellar fusion reactions also determined the electron configuration that gives water its life enabling properties. Even more remarkably, the elements in your body are not distributed randomly. They're organized according to the same principles that govern the structure of stars, galaxies, and the universe itself. The calcium that gives strength to your bones is arranged in crystalline structures that follow the same geometric principles found in mineral crystals throughout the cosmos. The iron in your hemoglobin is coordinated in complex molecular architectures that echo the way metals are organized in stellar cores. The DNA in your cells carries information encoded in a four-letter alphabet of nucleotides, each built from atoms created in different stellar environments. The phosphorus that forms the backbone of your genetic code was created in supernova explosions. The nitrogen in your nucleotide bases was forged in the cores of intermediate mass stars. The carbon that provides the structural framework was produced in red giant stars through the delicate triple alpha process. When you consider that your DNA contains the instructions for building a human being from stellar atoms, it becomes clear that life is not separate from the cosmic story. It's the latest chapter in that story. The same physical laws that govern nuclear fusion in stellar cores also govern the chemical bonds that hold your DNA together. The same electromagnetic forces that determine how atoms interact in space also determine how proteins fold in your cells. This deep connection extends to the very processes that sustain your life. The energy that powers your thoughts and movements ultimately comes from the sun, our local star, through the ancient process of photosynthesis. Plants capture stellar energy and use it to combine carbon dioxide from the atmosphere with water from the soil, creating the organic molecules that form the base of every food chain on Earth. When you eat, you're consuming reorganized stellar matter that has been temporarily arranged into the form of plants or animals. The glucose that fuels your brain was assembled from carbon atoms created in stellar cores using energy that traveled 93 million miles from our local fusion reactor. The complex proteins that build and maintain your body are constructed from amino acids whose elements were forged in the nuclear furnaces of ancient stars. Even your thoughts have a stellar connection. The electrical signals that carry information through your nervous system depend on the movement of ions, sodium, potassium, calcium, all of which were created in stellar cores and supernova explosions. The neurotransmitters that allow your brain cells to communicate are built from atoms that have journeyed across space and time from the hearts of dying stars to the synapses in your head. This cosmic perspective reveals consciousness itself to be a remarkable achievement of stellar evolution. Over billions of years, the universe has transformed simple hydrogen and helium into elements complex enough to form self-replicating molecules, which evolved into cells, then multicellular organisms, then nervous systems, and finally into brains capable of contemplating their own cosmic origins. You are the universe becoming aware of itself through billions of years of physical, chemical, and biological evolution. The same matter that once existed as simple gas in the early cosmos has been processed through stellar cores, scattered by supernova explosions, incorporated into planets, and ultimately organized into the intricate patterns of matter and energy that constitute your consciousness. When you wonder about the stars, you are stellar matter contemplating its own origins. When you feel awe at the beauty of the cosmos, you are the universe experiencing its own magnificence. When you love another person, you are organized star stuff caring for other organized star stuff in a dance of affection that spans from quantum interactions to cosmic evolution. This realization transforms our understanding of what it means to be human. We are not separate from nature, we are nature. We are not observers of the cosmic story, we are characters in it, and perhaps the most remarkable characters yet to emerge. We are the universe's way of experiencing beauty, creating art, making music, asking questions, and seeking understanding. The carbon in your fingertips, as you perhaps pull a blanket closer or adjust your pillow, was created in the core of a red giant star billions of years ago. That carbon has traveled across unimaginable distances and participated in countless chemical reactions before becoming part of you. Now it's enabling you to interact with your environment, to feel texture and temperature, to experience the physical world through touch. The oxygen flowing through your bloodstream right now was produced in a massive star that lived fast and died young, exploding in a supernova that briefly outshone an entire galaxy. That oxygen has enabled countless forms of life over geological time, and now it's enabling your existence, carrying energy to every cell in your body and making possible the complex chemistry of consciousness. As we continue our gentle exploration of these cosmic connections, we'll discover even more remarkable ways that we are woven into the fabric of the universe itself, and how the ongoing processes of stellar evolution continue to shape not just the cosmos around us, but the very nature of life and consciousness as we know it. The story of our cosmic heritage doesn't end with the creation of elements in stellar cores, or even with their assembly into the first organic molecules in the depths of space. There's another chapter to this tale, one that brings us even closer to home and reveals how the very planet beneath your feet participates in the ongoing dance of stellar recycling that connects us all to the cosmos. When our solar system began to form from a collapsing cloud of gas and dust, some 4.5 billion years ago, that cloud was already rich with the products of stellar death and rebirth. The heavy elements that would become the rocky planets had been through multiple cycles of stellar processing, scattered by ancient supernovas and stellar winds, then gathered again by gravity into new generations of stars and their accompanying planetary systems. Earth itself is a collection of stellar ashes, compressed and heated by gravity into a dynamic world where the products of cosmic nucleosynthesis continue to interact and evolve. The iron core at our planet's center, which generates the magnetic field that protects us from harmful cosmic radiation, is made of atoms forged in the final moments of stellar collapse. The silicon and oxygen that make up most of our planet's rocky mantle were created in the burning shells of massive stars just before they exploded as supernovas. Even the processes that shape our planet's surface are intimately connected to our stellar heritage. When volcanoes erupt, they're bringing to the surface materials that were created in stellar cores billions of years ago. The magma that flows from these volcanic vents carries with it the signatures of cosmic nucleosynthesis, elements that have journeyed from the hearts of ancient stars through the vacuum of space to become part of our living world. The atmosphere you breathe is itself a stellar creation. The nitrogen that makes up most of our air was produced in the cores of intermediate mass stars through a complex series of nuclear reactions. The argon that comprises nearly 1% of the atmosphere was created by the radioactive decay of potassium, itself a product of stellar nucleosynthesis. Even the carbon dioxide that plants use for photosynthesis carries carbon atoms that were forged in stellar furnaces when the universe was young. This planetary perspective reveals something profound about the nature of life on Earth. We often think of our world as separate from the cosmos, a kind of island of life floating in the hostile emptiness of space. But the reality is far more interconnected. Earth is not separate from the universe, it is the universe, organized into a particular pattern of matter and energy that happens to be conducive to the emergence and evolution of life. The soil beneath your feet, if you happen to be standing on the ground right now, is made of weathered rock that was created from stellar ashes. The minerals in that soil provide the nutrients that plants need to grow, nutrients that are ultimately incorporated into every living thing on our planet. The calcium that strengthens the cell walls of plants is the same calcium that was created in stellar cores. The phosphorus that plants use to store and transfer energy is the same phosphorus that was forged in supernova explosions. When you eat food grown in this stellar soil, you're participating directly in the cosmic recycling program that has been operating for billions of years. The vegetables in your dinner tonight contain atoms that have been on extraordinary journeys through space and time. The potassium in a banana was created by nuclear processes in ancient stars. The magnesium in leafy greens was produced in stellar cores that burned billions of years before our sun existed. The zinc in grains and nuts was forged in the violent final moments of stellar death. This agricultural connection to the cosmos means that farming is, in a very real sense, a form of stellar archaeology. Every harvest brings to our tables the products of cosmic evolution stretching back billions of years. The wheat that becomes bread, the grapes that become wine, the corn that feeds both humans and livestock. All of these crops are grown from stellar matter and nourished by elements created in the hearts of ancient stars. The water cycle that sustains all life on Earth is itself a cosmic phenomenon. The water that falls as rain was once part of comets and asteroids that formed in the outer reaches of our solar system, where stellar ashes had condensed into ice. When these icy bodies collided with the early Earth, they delivered not just water, but also organic compounds that had been synthesized in the cold depths of space from atoms created in stellar cores. Every drop of rain that falls carries with it the memory of its cosmic origins. The hydrogen in water molecules is nearly as old as the universe itself, created in the first few minutes after the Big Bang. The oxygen was forged in massive stars that lived and died billions of years ago. When these elements combined to form water in the outer solar system, they created a compound that would prove essential for the emergence of life. The oceans that cover most of our planet's surface are vast reservoirs of stellar matter, containing dissolved minerals and salts that were created in stellar cores and supernova explosions. The sodium and chlorine that make seawater salty were both produced by nuclear processes in ancient stars. The calcium and magnesium that marine organisms use to build their shells and skeletons were forged in stellar furnaces that burned when the galaxy was young. Marine life itself represents another chapter in the story of stellar matter becoming organized into increasingly complex patterns. The calcium carbonate shells of countless microscopic organisms sink to the ocean floor when they die, eventually forming limestone deposits that preserve the record of billions of years of life on Earth. These limestone formations are quite literally made of stellar ashes that have been processed through living systems, a kind of biological monument to the cosmic origins of life. The fossil fuels that power much of our modern civilization tell their own remarkable tale of stellar heritage. Coal, oil, and natural gas are the compressed remains of ancient life forms that lived hundreds of millions of years ago. The carbon in these fuels was originally created in stellar cores, then incorporated into the atmosphere as carbon dioxide, absorbed by ancient plants through photosynthesis, and eventually buried and transformed by geological processes into the energy sources we use today. When we burn fossil fuels, we're releasing carbon atoms that have been on an incredible journey from stellar cores to interstellar space to planetary atmospheres to living organisms to underground deposits and finally back to the atmosphere. It's a reminder that even our industrial activities are part of the ongoing cosmic story of matter cycling through different forms and organizations. The metals that form the backbone of our technological civilization also carry the signatures of their stellar origins. The copper in electrical wires was created in massive stars and scattered by supernova explosions. The aluminum in aircraft was forged in stellar cores through complex nuclear processes. The rare earth elements that make possible our computers and smartphones were created in some of the most extreme stellar environments, including the collision of neutron stars. Every piece of technology you use, from the device you might be listening to this on, to the infrastructure that delivered these words to your ears, is built from stellar matter that has been refined and organized by human ingenuity. We are using atoms created in ancient stars to build the tools that allow us to study and understand those very same stars. It's a beautiful example of the universe using part of itself to comprehend the whole. The rhythm of day and night that governs much of life on Earth is itself a cosmic phenomenon. The sun that rises each morning is a nuclear fusion reactor, converting hydrogen into helium and releasing the energy that sustains virtually all life on our planet. The light that warms your face and enables photosynthesis is the direct product of the same nuclear processes that created the heavy elements in your body, just happening on a much larger scale and in a much more controlled way. Our local star, the Sun, is itself made primarily of stellar ashes from previous generations of stars. While most of its mass is hydrogen and helium left over from the Big Bang, it also contains about 2% heavier elements, elements that were created in the cores of ancient stars and scattered into space by stellar winds and supernova explosions. These heavy elements, though a small fraction of the Sun's total mass, were essential for the formation of the rocky planets like Earth. The solar wind that streams constantly from our star carries with it atoms that were created in stellar cores, including some that originated in our own Sun's nuclear furnace. These particles travel across the solar system at hundreds of kilometers per second, and when they interact with Earth's magnetic field, They create the beautiful auroras that dance across our polar skies. In a very real sense, the northern and southern lights are made visible by atoms that are being created in our local star and scattered into space, continuing the ancient process of stellar nucleosynthesis and element dispersal. Even the moon that lights our nights carries within its rocks the record of cosmic bombardment from asteroids and comets made of stellar ashes. The lunar samples brought back by Apollo astronauts contain elements that were created in stellar cores billions of years ago, then incorporated into the bodies that collided with the moon during the early history of our solar system. When you look up at the moon tonight, you're seeing reflected sunlight bouncing off a surface made of stellar matter that has been pulverized and melted by eons of cosmic impacts. The seasonal changes that mark the passage of time on Earth are driven by our planet's orbit around the Sun and the tilt of its axis, but they also represent a deeper connection to cosmic cycles. The migration patterns of birds, the hibernation of mammals, the flowering of plants, all of these biological rhythms are ultimately synchronized with astronomical cycles that reflect our planet's place in the cosmic dance of stellar systems. Trees, those silent witnesses to the passage of seasons, are particularly elegant examples of stellar matter organized into living systems. The cellulose that gives wood its strength is built from carbon atoms created in stellar cores. The chlorophyll that enables photosynthesis contains magnesium that was forged in ancient stars. The annual growth rings that record each year of a tree's life are made of stellar ashes arranged in patterns that reflect the changing seasons and growing conditions of our planet. When you walk through a forest, you're moving through a community of organisms, all built from stellar matter, all participating in the ongoing cosmic story of increasing complexity and organization. The soil beneath the trees contains minerals weathered from rocks made of stellar ashes. The air between the trees carries gases whose constituent atoms were created in stellar cores. The sunlight filtering through the canopy brings energy from our local fusion reactor, enabling the chemical processes that sustain the entire ecosystem. This forest perspective reveals something profound about the relationship between life and the cosmos. We often think of nature as something separate from the cosmic story, something that happened after the universe had already been created. But the reality is that life is not separate from cosmic evolution. It is cosmic evolution, continuing by other means. The same processes of increasing complexity and organization that led from simple hydrogen to heavy elements in stellar cores have continued on Earth, leading from simple molecules to cells to ecosystems to consciousness. The seasonal cycles that govern much of life on Earth are themselves reminders of our cosmic context. Spring, when life awakens and begins another cycle of growth, is powered by increasing solar energy as our planet's orbit brings longer days to your hemisphere. Summer, when life reaches its peak abundance, represents the full flowering of stellar energy captured and organized by living systems. Autumn, when many plants prepare for dormancy, is a time when the products of stellar nucleosynthesis are stored and concentrated in seeds and fruits. Winter, when much of the natural world rests, is a quiet time when the cosmic processes continue, but at a slower pace, like the universe itself catching its breath. If you happen to be listening to this during one of these seasons, take a moment to appreciate the cosmic forces at work around you. The changing length of days reflects our planet's relationship with our local star. The migration of birds follows ancient patterns encoded in genes built from stellar atoms. The falling of leaves returns stellar matter to the soil, where it will nourish new growth in the continuing cycle of cosmic recycling. The weather patterns that shape our daily lives are also expressions of cosmic forces. The water that evaporates from oceans made of stellar matter rises into an atmosphere composed of gases created in stellar cores. The energy that drives these weather systems comes from our local fusion reactor, the Sun. When clouds form and rain falls, it's stellar matter returning to the surface in a different form, continuing the endless cycles that connect the cosmic and the terrestrial. Even the changing of seasons reflects our planet's place in a solar system that formed from stellar ashes. The elliptical orbit that brings us closer to and farther from the sun, the axial tilt that creates our seasons, the rotation that gives us day and night, all of these are consequences of the way stellar matter came together under the influence of gravity to form our planetary home. As you settle deeper into whatever comfortable space you've found for tonight's cosmic journey, perhaps you can feel in a new way your connection to these vast cycles of stellar death and rebirth, of cosmic recycling and renewal. The chair or bed supporting you is made of materials that were ultimately created in stellar cores. The air you're breathing contains atoms forged in ancient stars. The warmth of your body is sustained by chemical processes powered by energy that originated in our local fusion reactor. But our exploration of these cosmic connections is far from over. In the next part of our journey, we'll discover how the ongoing processes of stellar evolution continue to shape not just the physical universe around us, but the very possibilities for life and consciousness throughout the cosmos. We'll explore how the universe is still actively creating the conditions for new forms of complexity and organization, and how we ourselves are participants in this continuing cosmic story. For now, though, let yourself rest in the knowledge that you are intimately connected to the grandest story the universe has to tell. You are made of star stuff, but more than that, you are star stuff that has learned to wonder about stars, to ask questions about its own origins, and to find beauty in the cosmic dance that brought you into existence. The same atoms that once burned in the hearts of ancient stars now enable your thoughts, your dreams, and your capacity for wonder. Sleep well, fellow traveler in the cosmos, knowing that you carry within you the legacy of billions of years of stellar evolution, and that tomorrow you'll wake still connected to the infinite story of the universe, becoming aware of itself through your eyes, your thoughts, and your sense of wonder at the magnificent cosmic heritage we all share. The remarkable thing about our stellar heritage is that it's not just a story of the past. It's a living, breathing reality that continues to unfold with each passing moment. Right now, as you listen to these gentle words, the same processes that created the elements in your body are still at work throughout the universe, forging new atoms in stellar cores and scattering them across space through stellar winds and explosive deaths. In the constellation Orion, visible from most places on Earth during winter months, lies one of the most magnificent stellar nurseries in our galaxy. The Orion Nebula is a vast cloud of gas and dust where new stars are being born from material enriched by countless previous generations of stellar death and rebirth. If you could somehow speed up time and watch this region over millions of years, you would see gravity slowly gathering the stellar ashes into dense knots that eventually ignite as new suns, each one slightly richer in heavy elements than the stars that came before. Some of these newborn stars will be similar to our Sun, destined to burn steadily for billions of years, providing stable energy sources that could nurture the development of life on any planets that might form around them. Others will be much more massive, burning through their nuclear fuel in just a few million years before exploding as supernovae and adding their own contribution to the cosmic inventory of heavy elements. This ongoing stellar recycling program means that the universe is constantly becoming more chemically diverse, more capable of forming the complex molecules and structures that make life possible. Each generation of stars has access to a richer palette of elements than the one before, leading to an ever increasing potential for complexity and organization. The implications of this are profound. If the first stars that formed in our galaxy 13 billion years ago had planets, those worlds would have been made almost entirely of hydrogen and helium. They couldn't have had rocky surfaces, liquid water, or the chemical diversity necessary for life as we know it. It took billions of years of stellar death and rebirth to create the conditions that made Earth like worlds possible. We exist at a particularly fertile moment in cosmic history. The universe is old enough that many generations of massive stars have lived and died, enriching space with heavy elements, but young enough that smaller stars like our Sun are still burning steadily, providing the stable energy sources that complex life requires. In a sense, we live in the universe's sweet spot for the emergence of consciousness. But this stellar enrichment process is not distributed evenly throughout the cosmos. Regions of our galaxy that are rich in heavy elements, like the spiral arms where our solar system resides, are more likely to form rocky planets and develop complex chemistry. Areas that are metal poor, like the outer reaches of the galactic halo, remain dominated by the simple hydrogen and helium of the early universe. This means that life itself may be a rare and precious phenomenon, dependent not just on the right planetary conditions, but on being located in a region of space that has been sufficiently enriched by stellar death and rebirth. We are not just made of star stuff, we are made of particularly well processed star stuff, matter that has been through multiple cycles of stellar cooking and seasoning. The elements flowing through your bloodstream right now represent the cumulative work of countless stellar generations. The calcium strengthening your bones may have been created in a star that died 8 billion years ago, then incorporated into a second generation star that itself lived and died before being swept up into the cloud that formed our solar system. The iron carrying oxygen through your body might have been forged in a supernova explosion that occurred when our galaxy was young and chaotic, then drifted through space for eons before finding its way into the primordial Earth. Even more remarkably, some of the atoms in your body are still radioactive, carrying within their nucleus the memory of the violent stellar processes that created them. The potassium in your cells includes a small fraction of potassium 40, an isotope that was created in stellar cores and has been slowly decaying ever since. The carbon in your DNA includes traces of carbon 14 created when cosmic rays from distant stellar explosions strike nitrogen atoms in our atmosphere. These radioactive atoms serve as tiny clocks, marking the passage of time since their creation in stellar furnaces. The heat generated by their decay helps warm the Earth's interior, driving the geological processes that shape our planet's surface and maintain the conditions necessary for life. In a very real sense, you are kept warm by the dying embers of ancient stellar fires, radioactive atoms that have been slowly releasing their energy for billions of years. The cosmic ray particles that constantly bombard our planet carry with them the signatures of stellar violence from across the galaxy. These high energy particles, accelerated to tremendous speeds by supernova shockwaves and other stellar catastrophes, rain down on Earth continuously, occasionally interacting with atoms in our atmosphere to create new isotopes and even triggering mutations in living organisms. Some scientists believe that cosmic rays may have played a role in the evolution of life on Earth, providing just enough genetic variation to drive natural selection while not being so intense as to sterilize our planet. If this is true, then we owe our existence not just to the atoms created in stellar cores, but to the ongoing violence of stellar death and rebirth throughout our galaxy. The magnetic field that protects us from the most harmful cosmic radiation is itself generated by the motion of liquid iron in Earth's core iron that was created in the final moments of stellar collapse billions of years ago. This invisible shield, sustained by stellar matter in the heart of our planet, creates the safe harbor in which life has been able to flourish and evolve into forms of extraordinary complexity and beauty. When you look up at the night sky on a clear evening, you're seeing not just distant lights, but an active stellar ecosystem, a vast network of nuclear furnaces at different stages of their life cycles. Some of the stars you see are young and hot, burning their hydrogen fuel at a prodigious rate and destined to live only a few million years. Others are ancient red giants, swollen and cool, gently puffing off their outer layers in stellar winds that will enrich the surrounding space with heavy elements. A few of the points of light you observe are actually binary systems, pairs of stars locked in gravitational embrace, sometimes transferring matter from one to the other in spectacular displays of stellar cannibalism. Occasionally, these stellar partnerships end in catastrophic explosions that can briefly outshine an entire galaxy, creating and scattering elements that will become part of future worlds and perhaps future life. The Milky Way galaxy itself, that faint band of light stretching across the darkest skies, is a vast stellar recycling facility containing hundreds of billions of stars at various stages of element creation and distribution. The spiral arms where our solar system resides are regions of active star formation, where the ashes of dead stars are being gathered into new stellar nurseries and transformed into the next generation of suns and planets. From our perspective within this galactic system, we can observe the ongoing process of cosmic chemical evolution that created us. The heavy elements that make up our planet and our bodies are still being produced in stellar cores throughout the galaxy. The gold in any jewelry you might be wearing is still being created in neutron star collisions. The oxygen you breathe is still being forged in the cores of massive stars that will one day explode and scatter their nuclear ashes across space. This perspective reveals something profound about our relationship with time and space. We often think of ourselves as existing in a particular moment, at a specific location, separate from the vast scales of cosmic evolution. But the reality is far more interconnected. The atoms in your body are billions of years old, created in stellar furnaces when the universe was young. They have traveled vast distances across space and time to become part of you, and they will continue their cosmic journey long after your consciousness has faded. In this sense, you are not just a temporary arrangement of stellar matter, you are a conscious node in the ongoing network of cosmic evolution, a point where the universe has become aware of itself and can contemplate its own history and destiny. The thoughts passing through your mind right now are the universe thinking about itself through patterns of neural activity made possible by stellar nucleosynthesis. When you feel wonder at the beauty of a sunset, you are stellar matter appreciating the light from our local fusion reactor. When you experience love for another person, you are organized star stuff caring deeply about other organized star stuff. When you create art or music or poetry, you are the cosmos expressing its own creativity through the temporary pattern of complexity that is your consciousness. This realization transforms our understanding of death and continuity. While your individual consciousness may be temporary, the atoms that make up your body will continue their cosmic journey indefinitely. The carbon in your cells will eventually return to the atmosphere and become part of other living things. The calcium in your bones will weather into soil and nourish new growth. The iron in your blood will one day flow through other circulatory systems, carrying life to other conscious beings. In this way, death becomes not an ending, but a transformation, a changing of the patterns in which stellar matter is organized. The same atoms that currently enable your thoughts and experiences will go on to enable other thoughts and experiences, participating in forms of consciousness and complexity that we can barely imagine. The water you drink connects you to this vast temporal network. Every glass of water contains molecules that have been part of clouds and rain, rivers and oceans, plants and animals for millions of years. Some of the water in your body was once part of dinosaurs, ancient trees, early humans who lived thousands of years ago. It has cycled through countless living systems, carrying with it the chemical memory of Earth's biological history. The air you breathe tells a similar story. The oxygen entering your lungs right now may have been released by a tree in a distant forest, or by phytoplankton in a remote ocean, or by ancient cyanobacteria that lived billions of years ago when our planet's atmosphere was first being transformed from a toxic mixture to the life-supporting blend we depend on today. Even the carbon dioxide you exhale will continue its journey through the global carbon cycle. Some of it will be absorbed by plants and converted into organic compounds through photosynthesis. Some will dissolve in the oceans and become part of marine ecosystems. Some will remain in the atmosphere for years or decades before being incorporated into living systems, and some will eventually be buried in sediments and transformed into the fossil fuels that future civilizations might discover and use. This perspective reveals the profound interconnectedness of all life on Earth. We are not separate individuals competing for resources. We are temporary organizations of stellar matter, sharing the same cosmic heritage and participating in the same grand story of increasing complexity and consciousness. The boundary between self and environment, between organism and ecosystem, between Earth and cosmos, begins to dissolve when seen from this stellar perspective. The seasonal rhythms that govern much of life on our planet are expressions of our cosmic context. The migration of birds follows patterns encoded in genes built from stellar atoms, synchronized with astronomical cycles that reflect our planet's journey around our local star. The flowering of plants is timed to take advantage of solar energy that began its journey in nuclear fusion reactions in the sun's core. When autumn leaves fall and decay, they're returning stellar matter to the soil where it will be recycled into new growth. The brilliant colors of fall foliage are created by complex organic molecules built from atoms forged in ancient stellar cores. The glucose and other compounds that trees produce during their growing season are concentrated forms of stellar energy, captured from sunlight and stored in chemical bonds for future use. Winter's dormancy is not death, but a pause in the active cycling of stellar matter through living systems. The seeds that wait buried in snow or soil contain within their protective shells the genetic instructions for rebuilding complex organisms from simple molecules, instructions encoded in DNA built from atoms created in stellar furnaces billions of years ago. Spring's awakening is powered by increasing solar energy as our planet's orbital mechanics bring longer days and warming temperatures. The first green shoots pushing through the soil are stellar matter reorganizing itself into new patterns of life, continuing the ancient dance of cosmic recycling that connects the smallest seed to the grandest galactic processes. The food webs that connect all living things on Earth are networks for the circulation of stellar matter. When a plant captures carbon dioxide from the atmosphere and uses solar energy to convert it into glucose, it's organizing stellar atoms into biological molecules. When an animal eats that plant, it's reorganizing those stellar atoms into different biological structures. When that animal dies and decomposes, it's returning stellar matter to the soil where it can be incorporated into new living systems. Every ecosystem on Earth, from the deepest ocean trenches to the highest mountain peaks, is a local expression of the cosmic recycling program that has been operating for billions of years. The wolves in Yellowstone, the coral reefs of the tropics, the bacteria in your gut, all are temporary organizations of stellar matter, participating in the ongoing story of cosmic evolution. The remarkable thing is that this process is not random or chaotic. Despite the violent origins of the elements in stellar cores and supernova explosions, life has emerged as an organizing principle that creates patterns of extraordinary beauty and complexity from stellar ashes. The same matter that was once scattered by stellar explosions has been gathered by gravity, organized by chemistry, and refined by evolution into the intricate structures that make consciousness possible. Your brain, reading these words and contemplating their meaning, is perhaps the most complex organization of stellar matter yet discovered in the universe. The 100 billion neurons that enable your thoughts are connected by trillions of synapses, creating a network of staggering intricacy built entirely from atoms forged in ancient stellar cores. The electricity flowing through these neural networks, carrying the patterns of activity that constitute your consciousness, is made possible by the movement of ions whose elements were created in stellar furnaces. The neurotransmitters that allow your brain cells to communicate are built from stellar atoms arranged in precisely the right configurations to enable the chemical conversations that generate thought, emotion, memory, and awareness. When you remember a childhood experience, you're using molecular machinery built from stellar ashes to access patterns of neural connectivity that encode information about your past. When you imagine a possible future, you're employing stellar matter organized into predictive networks that can model scenarios that don't yet exist. When you feel love or compassion or wonder, you're experiencing emotions generated by stellar atoms arranged in the exquisite complexity of the human nervous system. This perspective reveals consciousness to be not separate from the physical universe, but its most remarkable achievement so far. We are the cosmos, becoming aware of itself through billions of years of stellar death and rebirth, planetary formation, chemical evolution, and biological development. We are star stuff that has learned to think, to feel, to create, and to contemplate its own origins. The books you read, the music you listen to, the art you admire, all are expressions of stellar matter organized into patterns of extraordinary creativity and beauty. The love you feel for family and friends is stellar atoms caring deeply about other stellar atoms. The questions you ask about the meaning and purpose of existence are the universe wondering about itself through the medium of human consciousness. As you settle deeper into whatever peaceful space you've chosen for tonight's cosmic journey, perhaps you can feel in a new way your participation in this grand story. You are not just made of star stuff, you are star stuff that has achieved the remarkable ability to understand and appreciate its own cosmic heritage. You are the universe celebrating its own creativity and complexity through the temporary but magnificent pattern of organization that is your consciousness. The gentle rhythm of your breathing connects you to the atmospheric cycles that have been operating for billions of years, circulating stellar atoms between living systems and the environment. Your heartbeat echoes the pulsations of variable stars across the galaxy, stellar hearts that beat with rhythms measured in days or years rather than seconds. The warmth of your body is sustained by chemical processes that ultimately trace back to nuclear fusion in our local star. The same electromagnetic forces that hold atoms together in stellar cores also hold together the molecules that make up your cells. The same gravitational force that compresses stellar cores to the temperatures needed for fusion also keeps your feet planted firmly on a planet made of stellar ashes. In a very real sense, you are not separate from the stars. You are a star, a temporary concentration of stellar matter that has achieved the extraordinary feat of self-awareness. You are a walking, talking, dreaming piece of the cosmos, carrying within you the memory of stellar births and deaths stretching back to the very beginning of the universe. Tomorrow, when you wake, you'll still be made of star stuff, still participating in the ongoing cosmic story of matter organizing itself into patterns of increasing complexity and beauty. And somewhere in the galaxy, new stars will be born from the ashes of old ones, continuing the endless cycle of stellar death and rebirth that connects us all to the deepest mysteries of existence. But tonight, rest peacefully, knowing that you are intimately woven into the fabric of the cosmos itself. The same atoms that once danced in the hearts of ancient stars now dance within you, enabling your thoughts, your dreams, and your sense of wonder at the magnificent universe that created you and of which you remain forever a part. And so, dear fellow traveler, we arrive at the gentle end of our cosmic journey together. Though in truth there is no real ending to this story, only a pause, a moment to rest before the universe continues its eternal dance of creation and renewal. As you settle into whatever peaceful corner of the world you call home tonight, take with you this profound truth: you are not merely an observer of the cosmic story, you are the story itself. Every breath you take connects you to stellar winds that have blown across the galaxy for billions of years. Every heartbeat echoes the rhythmic pulsations of stars being born and dying in distant nebulae. Every thought that passes through your mind is the universe contemplating its own magnificent complexity through the temporary but extraordinary pattern of consciousness that is you. The calcium strengthening your bones was forged in the nuclear furnace of a dying star. The iron carrying oxygen through your bloodstream was created in the violent final moments of stellar collapse. The carbon forming the backbone of your DNA was cooked slowly in the core of a red giant that burned for millions of years before gently releasing its treasures into space. You are quite literally made of star stuff. But more than that, you are star stuff that has learned to wonder about stars. When morning comes and you wake to sunlight streaming through your window, remember that you're seeing the direct product of nuclear fusion happening 93 million miles away in our local stellar furnace. That light began its journey in the sun's core, where hydrogen atoms created in the first moments after the Big Bang are still being transformed into helium, releasing the energy that sustains virtually all life on Earth. The seasonal changes that mark the passage of time around you are cosmic rhythms made visible. Spring's awakening is powered by increasing solar energy, as our planet's orbital dance brings longer days. Summer's abundance represents the full flowering of stellar energy captured and organized by living systems. Autumn's preparation reflects the cycling of stellar matter through ecosystems preparing for winter's rest. And winter's quiet dormancy is the universe itself taking a gentle breath before beginning the cycle anew. You are part of an ongoing cosmic recycling program that has been operating for over 13 billion years. The atoms that currently make up your thoughts and dreams will outlast you by eons, continuing their journey through the endless cycles of stellar death and rebirth, planetary formation and dissolution, the emergence and evolution of life in forms we can barely imagine. In the far future, when our sun swells into a red giant and gently puffs off its outer layers, some of the atoms that are currently part of your consciousness will be carried on stellar winds across the galaxy to seed new worlds and perhaps new forms of awareness. The carbon in your cells may one day become part of an alien forest on a world that won't exist for billions of years. The oxygen in your bloodstream may help sustain life forms so different from us that we couldn't recognize them as living. This cosmic perspective transforms everything. We are not separate individuals struggling alone in an indifferent universe. We are temporary but precious organizations of stellar matter, sharing the same cosmic heritage and participating in the same grand story of increasing complexity and consciousness. We are the universe's way of experiencing beauty, creating art, feeling love, and asking the deepest questions about existence itself. So when you feel small or insignificant, remember that you carry within you the legacy of stellar generations stretching back to the very beginning of time. When you experience wonder at a sunset, or feel moved by music, or touched by the love of another person, you are stellar matter celebrating its own extraordinary journey from the hearts of ancient stars to the miracle of consciousness. The next time you look up at the night sky, know that you are not gazing at something foreign and distant. You are looking at your stellar ancestors, the cosmic furnaces that forge the very atoms of your existence. Those points of light twinkling in the darkness are your family, your heritage, your home in the deepest sense possible. If this gentle exploration has brought you peace, if it has helped you feel more connected to the vast and beautiful cosmos of which you are forever a part, I would be ever so grateful if you shared this cosmic wonder with others who might need reminding of their own stellar heritage. Perhaps give this video a gentle thumbs up or subscribe to join our quiet community of cosmic wanderers who find comfort in contemplating their place among the stars. And now it is as the ancient atoms that make up your eyelids grow heavy and your breathing settles into the rhythm of approaching sleep. Know that you are about to dream with a brain built from star stuff, to rest in a body forged in stellar cores, to sleep peacefully on a planet made from the ashes of countless stellar generations. You are made of star stuff, dear friend, and that makes you part of the most beautiful story the universe has ever told. The story is not ending tonight. It is simply turning to a new page, one that will be written tomorrow by the same stellar atoms that are settling into rest within you right now. Sleep well, fellow star child, and dream sweetly of the cosmic dance that brought you into existence and of which you will forever remain a cherished part. The universe sleeps within you tonight, and when you wake, you will carry forward the endless story of stellar matter, learning to love, to wonder, and to find its way home among the stars. Sweet dreams made of star stuff.